My name is Nate Denton, and this is my project 2.1 digital to analog converter. It works using R2 and R2 resistors and relies on superposition as one theory and Theverin's, sorry if I pronounced that wrong, theorem, both of which will be explained later in the video. This is the breadboard prototype. It works in much the same way, using 5% resistor errors marked by the gold ring instead of the 1% resistors used in the final. It uses main parts include the dip rocker switch, 1 kilo ohm resistor network that runs along the back, bringing pull down current. Each dip switch is provided with about 5-volt power, and the resistors for R are 330 ohm and 2R are 680 ohm. So it's not perfect, but it will give fairly accurate results as it is almost a R to 2R resistance. This equivalently relies on the two theorems previously mentioned. Getting a bit big, but here is how Theverin's theory works. Basically, if we have equal linear circuits with equal voltage coming across it, as we can see coming up the top, then we can slowly cancel out, assuming none of them. Yeah, assume no voltage. So these two become half, and since they're twice of R, it just becomes R, which turns into this, and then R plus R just becomes 2R, and that becomes that, and that is badly placed. And this pattern can keep repeating because now we have the same thing here, 2R, R, another R there, and that just becomes a slightly, there we go, that, and that pattern just continues all the way along until we eventually get to this, and then we get to this. But as you can see here, we have this again, and if we have both 2R's again, and if we just slide this off, we get, if I can bend my paper correctly, R is out. And that just means that this entire circuit is basically equal to just the value of R, which for my circuit is 5.1 kilo ohms of resistance. And superposition is another big theory in this, and superposition is basically where each of these values add up together. So if, let's say, current 2 is on and current 4 is on, then those two will add up, though I'm not actually going to use those two for the example. So if, let's say, 6 and 7 are on, jokes aside, if voltage 6 and 7 are on, then 2R, then superposition, and this, and we get back to Theverin's theory back here, it comes back together, and we get to this, as none of that really matters. So realistically, we get to this, and then the voltage basically gets halved each time. So for purposes of simplicity, we're gonna say 6 is on. So we have 5 volts coming in, or just any amount of voltage really. a 1 over voltage over the current, or over 2, and then it eventually gets to over 4 and over 8. Not the best way of explaining it, but the basic idea is that as you move on the voltage, or 1 over, I guess, as of the number doubles to the power of 2. Yeah.